Hello, so this is my chemistry video on chapter 9 for chemical names and formulas, and I will be doing the level 4 assignment. Okay, let's get started on that. Okay, so the first section is explain what is wrong with the formulas and correct the mistakes. So let's do the first one, which is right here, ClNA. So what's wrong with that? So we can see that it's chlorine and Na, which is, let me go here, I'm pretty sure that's sodium. But the equation is actually written backwards. It's supposed to have the Na, which is the cation, first, and then chlorine, which is the anion, second. So the actual equation should have been like this. So for number 1, it would have been NaCl. And since they're both one negative, or one positive and one negative, they don't have to put any numbers. Okay, so for number 2, it is Ba2CO3 2. So we can see Ba2 right here, and then CO3 2, which is carbonate, and carbonate we know has, so CO3 has a charge of 2 negative. And since Ba right here has a charge of 2 positive, we don't need these exponent or these numbers, subscripts, to show how many there are. So the actual equation would just be BaCO3 because they both cancel each other out. And then number 3, iron nitrate. So iron nitrate, so we know nitrate, the formula is NO3 just minus. So, and an iron, since it's one of these weird transition metals right here, where's iron? Iron's right here, Fe. It can have two different charges, so you have to specify that when you write it. So since nitrate has a negative charge, I don't think there's an iron 1, but I think you can write iron 2 or 3. Okay, so I'm just going to put iron 3 nitrate. So we can specify that there are 3 irons. And yeah, so not 3 irons, that the charge of iron is 3, sorry. Yeah, that's people get confused. Anyways, the next one, dipotassium monosulfide. So if we look at potassium right here is K, right? Yeah, potassium is K, and that has a charge of 1 plus, or plus, yeah, 1 plus. And sulfide, or sulfur, has a charge of 2 minus. So you would need 2 potassium to counteract the sulfur. Wait. Oh, wait, no. Yeah, but this is wrong because if you look at potassium right here and sulfur right here, potassium is a metal while sulfur is a nonmetal. And since you're binding a metal and a nonmetal, this is actually ionic. And you don't need to write the prefixes mono and di, so it'll just be potassium sulfide. Yeah. Okay, moving on to the next one. Okay, so now we're going to talk about, illustrate the law of definite proportions and the law of multiple proportions. So, law of definite proportions, it states that basically in a compound, the masses stay in the same proportion between the elements. So, if you have, in theory, then if you had like carbon and oxygen, and then you had 100 grams of this, and let's say carbon weighed like 554, and then carbon weighed like 36, then they would always stay in a proportion of 36 to 54. So if you want to do this actually, you can see like magnesium sulfate, which is MgS. If you have 100 grams of that, then you would obtain 43.13 grams of magnesium, and then 56.87 grams of sulfur, or yeah, and then, oh, did I say magnesium? So I meant magnesium sulfide. So then your proportion will always stay the same at 43.132. Let me move this. 43.13 to, what was the number? Oh wait, let me go back. 56.87. And yeah, so then it will stay in this fixed ratio for no matter how much you have. But then you can simplify this ratio to like 0.758 for every one. So that would be 0.58 grams of magnesium for every one sulfate. And yeah, so that you can use that no matter how much grams of the oh sorry, no matter how many grams of the compound you have, the proportion will stay the same throughout that. Okay, so now we can go to the next one. Okay, so this one is going to be the law of multiple proportions. So let's move over here. Anyways, okay, so this law states that, let's say the two elements that we use in the equation, we can use like hydrogen and oxygen, right? Let's say it's like H2O, right? That's water. Let's say they can make two, and they can. So they have H2O, and they also H2O2. So there's two different compounds that can be created with these two elements. And this law states that the different masses of one of the elements that combine with the same mass of the other element are in a ratio of small whole numbers. So basically, since hydrogen, so we have H2O2 and H2O, hydrogen, there's always two hydrogen in these two equations, so that stays the same. But we can make a small whole number ratio with these two right here, like the oxygen, because there's two oxygen in this one and one oxygen in this one. So we can use the first property, which stated that their masses stay the same in the proportion, right? And then, so we can use that in here, stating that, so let's say H2O2 right here. For 1 gram of hydrogen, there's always 16 grams of oxygen, and for 1 gram of hydrogen, there's always 8 grams of oxygen in water. And you can see that it doubles because there's 2 oxygen in this one, and there's only 1 oxygen in here. So you can write the ratio, right, this, and then it will be 16 to 8, and that can be simplified to 2 to 1. And yeah, that ratio is created because they're using the same two elements, hydrogen and oxygen, but in different quantities. So the hydrogen stays the same, but the oxygen, there's more or less. Yeah. And yeah, that's the end of my video. Bye. Oh.